Look at your hand right now. Whatever shade it is, whether you are super pale, enough to blend into a blank sheet of paper, or dark enough to soak up sunlight, like a solar panel, that skin color didn't just happen. It actually came from one of the absolute wildest, most dramatic makeovers in the entire history of life on Earth. And the craziest part, it wasn't random. It was no accident. It wasn't some lucky roll of the cosmic dice. It was a survival struggle, a slow biological negotiation between our ancestors and the sun. And that sun, by the way, was definitely not playing fair. So, how'd we survive? The answer involves vitamin D, cancer, folate, Africa, and ice ages, plus ancient farmers who accidentally hacked their very own evolution. And a surprisingly rude star sitting 93 million miles away from us that triggered all of this and has absolutely no regrets. If you trace our human family tree all the way back, every single one of your ancestors, no matter where you are from today, had dark skin. Every single one. Not just most of them, not a simple majority, every single one. Around 300,000 years ago, when Homo sapiens first showed up in Africa, the entire species was dark-skinned. There were zero pale people. There were no fair-skinned populations anywhere on the planet. The very idea of light skin did not even exist yet in humans. Now, think about that for a second. Every person you had ever seen in a history book, every ancient civilization, every mythology, every cave painting, all of it traces back to a single founding population that looked nothing like a massive chunk of our modern human species. Which means, way back in history, something clicked, something changed, and that shift was so powerful, deeply wired into our very DNA, rewriting how we actually look, for whole populations across different continents over thousands and thousands of years. So, what triggered it? Before we get there, we have to understand something about our own skin. Honestly, most people have no real clue what skin really is, or what it is doing for you this very second. Many of us view skin as if it is just wrapping, like the leather bag your body arrived in, holding all your squishy organs together while you walk around, fighting with strangers on the internet. But skin is a complex organ, our largest, as a matter of fact, running about 47 different jobs at once, most of which we never think about, let alone show any gratitude for. One of those crucial tasks, and maybe the most vital, is shielding us from ultraviolet rays, that invisible, high-energy light the sun constantly fires right at the earth. And believe me, it is not your friend. Ultraviolet light tears chemical bonds apart, scrambling your DNA and causing mutations in your cells. If those genetic mistakes pile up in the wrong spots for too long, they can trigger cancer. Specifically, melanoma, one of the most aggressive, fast-moving types of cancer out there. Now, here is where skin color gets interesting. The natural pigment giving skin its unique color is melanin. And melanin is, in a very literal biological way, our built-in, natural sunscreen. An always-on ultraviolet shield. The more melanin you have, the darker your skin becomes, and the better it blocks harmful UV rays from penetrating deep into your skin layers where your DNA resides. Dark skin isn't just a fashion choice, it is a shield. That is why Africa, where our ancestors first evolved, right under some of the most intense solar radiation on the entire planet. Natural selection worked hard and fast for dark skin. More melanin meant your DNA got maximum protection. It meant you were less likely to develop cancer-causing DNA mutations. It meant you lived longer, stayed healthier, and, most importantly from evolution's cold, calculating perspective, you were more likely to survive long enough to reproduce and pass your genes to the next generation. Natural selection is essentially a slow, completely ruthless optimization algorithm. It does not care about looks. It does not have opinions on beauty, and it doesn't wake up in the morning with a vision of what the human species should look like. It just runs one calculation over and over again, running billions of times across billions of living organisms. Does this trait help you survive long enough to have offspring? If yes, keep it. If no, eliminate it. In equatorial Africa, under that scorching sun, dark skin was a solid, emphatic yes. Every generation, every single time. But here is the thing. And this is where the story gets genuinely, surprisingly complicated. Ultraviolet radiation does not just attack skin cells. It also targets something inside your body, something tiny, completely invisible, and absolutely crucial, something that, if you destroy it in the wrong person at the wrong moment, can end a pregnancy before it can even begin. This molecule in question is called folate. It is vitamin B9, and it travels through your bloodstream doing essential day-to-day bodily upkeep. So, you might be thinking, alright, vitamin B sounds like something my doctor tells me to take more of. Why does this affect skin color? Actually, it matters enormously, especially if you want to get pregnant anytime soon. Folate is crucial for the development of an embryo's neural tube, that is the essential structure that eventually becomes the brain and spinal cord. Without enough folate in those critical first weeks of pregnancy, sometimes before a mom even knows she is expecting, that neural tube might fail to close up right. The consequences are devastating: severe birth defects, major developmental issues, miscarriage. And here is the catch. UV rays actually destroy folate. When UV rays penetrate the skin and reach the bloodstream, they break down those folate molecules. In sun-soaked places like equatorial Africa, with no clothes, no shelter, no sunscreen, sun exposure was constant, intense, and unavoidable. This caused another massive, devastating evolutionary pressure. Expecting mothers with lighter skin, less melanin, and deeper UV ray penetration had higher rates of folate loss. This folate destruction meant much higher rates of neural tube defects. More neural tube defects meant far fewer surviving babies. So, now we have not one, but two completely separate reasons why dark skin became so heavily, non-negotiably favored under that harsh African sun. First, melanin protected DNA from UV damage, lowering risk. 2. It protected folate in pregnant. For women, protecting reproductive success. 2 threats, 1 biological shield. Defense. Back in Africa, dark skin wasn't just helpful. It was absolutely crucial for the survival of our species. So, dark skin is this ultimate, multi-purpose biological shield. It blocks cancer, saves folate, and has been field-tested and perfected over hundreds of thousands of years. If evolution had an online review system, dark skin gets a 5-star rating with thousands of perfect reviews. So, why on earth did this logic break down and things change? Why did early humans leaving Africa end up becoming paler and paler over thousands of years? It comes down to a beautifully brutal compromise in the history of human evolution. Around 70 to 100,000 years ago, bands of Homo sapiens started leaving Africa. This was no sudden, dramatic exodus. Nobody called a big meeting. No one planned a massive migration, just a slow, generational drift. One family wandered a bit further than their parents ever did. The kids went even further. Over thousands of years, they spread through the Middle East, up into Europe, across Asia, and finally into the Americas. As they pushed north, something massive in their environment shifted. The sun grew weaker. Well, not literally. It stayed just as harsh and intense as it always was. But up north, those solar rays strike at a much lower angle, filtering through way more atmosphere before it reaches you. UV radiation gets filtered out. Days are shorter, and winters are long and dark. The sky stays overcast for months. Across northern Europe, northern Asia, and in Canada, the UV environment is radically different from the hot equatorial Africa. Instead of that relentlessly intense sunlight you need to block, you get weak, patchy rays that you desperately need to absorb. And suddenly, that dark skin so perfect for Africa became a real problem. Not from cancer, since cancer risk in northern latitudes with weak UV was much lower, nor because of folate. Less UV meant less breakdown, so that was fine. No. The real problem was something else, something that rarely gets the credit it deserves in this story. Vitamin D. Your body makes vitamin D in the skin when UVB rays strike a compound called 7-dehydrocholesterol. Think of your skin as a solar panel. It uses natural sunlight as energy to help produce this vital molecule, and vitamin D isn't optional, not even a single bit. It is absolutely critical to keeping us healthy. It regulates calcium and phosphorus, absorption inside your gut. Without it, your body can't properly absorb it, no matter how much dairy you eat. Without calcium, your bones don't develop correctly. In children, severe vitamin D deficiency causes rickets, a painful disease that softens and deforms bones, bowing the legs outward and flattening the skull, while stunting growth. In adult women, vitamin D deficiency causes a condition called osteomalacia, which actually softens your pelvic bones, and those soft, weak pelvic bones make giving birth incredibly dangerous, sometimes literally impossible. Mothers with low vitamin D levels face shockingly high death rates during delivery. But this vitamin shortage does not stop with your bones. It wrecks your immune system, leaving you open to deadly infections. It hits muscle strength and even impacts heart health. Some science even connects low levels to deep depression and brain decline. This single nutrient does so much heavy lifting that when you run dry, your body starts failing in several ways at once. Now, drop a dark-skinned person in Northern Europe 40,000 years ago. They possess highly protective melanin. Their skin blocks harsh sunlight dutifully, which is fantastic in sunny Africa. But in cloudy, low-light northern skies, that same melanin blocks the tiny bit of UV they desperately need to make vitamin D. Their skin cannot tell the difference between dangerous rays to block and helpful rays they desperately need. It just blocks everything. They do not get enough essential vitamin D. Their calcium absorption plummets. Their bones grow weak. Their kids develop rickets, and mothers die in labor. The entire population starts shrinking. Having dark skin up north was not just a slight disadvantage. Back then, without dietary supplements or fortified food and advanced medicine, it was a slow death sentence across generations and evolution, cold and utterly brutal. That patient, silent calculator, started weeding it out. Mutations that lowered melanin production finally started appearing in population. Just random genetic mutations, always do. But instead of disappearing, they actually spread because people with slightly lighter skin made slightly more vitamin D, had slightly stronger bones, and had better reproductive success. Generation after generation, skin got lighter, lighter, and even lighter. Over thousands of years, the typical skin tone of northern populations drifted lighter, not because anyone planned it, not because of local culture or fashion trends or social pressure, but because in that precise climate, at that specific latitude, with that exact amount of sunshine, lighter skin kept more people alive. The evolutionary code simply reversed its inputs. For a long time, scientists assumed pale skin in European populations happened slowly over hundreds of thousands of years, a slow, steady evolutionary drift as people moved north. But ancient DNA analysis has completely shattered that assumption and replaced it with something way more interesting. Early European hunter-gatherers, the people who lived in Europe for tens of thousands of years after their first journey out of Africa, were still remarkably dark-skinned. Even after living in those northern latitudes for a long time, they had not dramatically tailed. The most famous example is a skeleton known as Cheddar Man. He lived in what is now Britain roughly 10,000 years ago. Ancient DNA analysis from 2018 revealed he likely had dark to medium dark skin, dark curly hair, and blue eyes, a combination that looks almost totally bizarre to modern eyes because we tend to link blue eyes with very pale skin. But 10,000 years ago, that was not the case. That ultra-fair skin we associate with modern Northwestern Europeans, the kind that burns in 12 minutes of summer sun, only started spreading widely across populations in Europe roughly 6 to 8,000 years. That is incredibly recent, right? Across 300,000 years of Homo sapiens, that is under 3%. So, what happened 6 to 8,000 years ago to speed this process up so dramatically? The answer is actually one of the biggest shifts in history, yet almost nobody links it to skin color. Enter the massive Neolithic revolution, the big shift from hunting and gathering to farming. When our ancestors switched to growing food, their diets changed forever. Like, completely. Early foragers ate a diverse diet that was packed with serious amounts of essential vitamin D. Think fatty salmon and fresh mackerel, rich organ meats like wild liver and shellfish. Basically, things that are some of the richest sources of vitamin D around. But farmers, they lived on wheat and barley, heavy, starchy carbohydrates. Their vitamin D levels did not just drop, they absolutely cratered. Suddenly, early humans who had been surviving on a bit of ultraviolet, made vitamin D because their diet helped out, were suddenly left almost reliant on only what their own skin could make itself. But with darker skin back then, it simply was not enough. Evolutionary pressure for lighter skin got way more intense. Even tiny boosts to your vitamin D production, or just having slightly less melanin, became incredibly crucial for survival. But a second force sped things up even more. Those early farming towns were big and packed tight, and they stayed put. Population size and density totally changed the game on how fast a helpful genetic mutation can spread through a population. In a small, roaming tribe of 50 people, a helpful mutation might take ages to even reach the next tribe over. But in a village of hundreds, linked to a whole web of other settlements, that helpful gene can sweep through thousands of descendants in just a few generations. Mix that lack of vitamin with packed, crowded living, and it basically slammed the fast-forward button on lighter skin tones. In just a few thousand years, that evolutionary pressure that had been slowly coaxing skin tones lighter for thousands of years suddenly went into overdrive. Fast, clear, and obvious in the record. Here is a wild fact that shocks people when they first learn it. Skin color is not run by just one single gene. There is no dark gene fighting a light skin gene where one wins out. It's way more complicated than that. Your skin tone is a team effort. It's run by dozens of different genes all working together. Some decide exactly how much melanin your body makes, what kind of it is, how those color granules get packed inside your cells, and how your skin handles UV rays over generations. And here is the really crazy part. Different groups of people who independently developed lighter skin did not use the exact same genes. For instance, East Asians and Europeans today both have much lighter skin tones than Equatorial Africans, yet the specific genetic changes behind pale skin in East Asians are mostly different from the ones we find in Europeans. They reach the same result using completely different routes. Scientists call this convergent evolution. It is like nature finding one solution for low sunlight areas, found entirely through different genetic pathways by different populations living on different continents. Let that sink in. The evolutionary pressure was so intense, so constant, and so clear that natural selection solved the same puzzle multiple times, not just once, either, but repeatedly, independently. When nature keeps rebuilding something from scratch, that is the loudest signal that biology ever gives us that the trait we are looking at really matters for staying alive. Since we are talking about genetics, let us look at something else that is just as wild: blue eyes. Every single person alive today with blue eyes, literally every one of them, zero exceptions, comes from one specific person, one genetic glitch, one moment somewhere near the Black Sea, maybe 6,000 to 10,000 years ago. Before that single human was born, the entire human race had brown eyes, just brown eyes. Everywhere you looked, as far back as you could go. Then, a single tiny mutation appeared, a tweak that dialed down melanin production, right in the iris, and it spread, slowly at first, then incredibly fast, likely because it was genetically hitched to lighter skin tone variants, which were already being heavily favored. Naturally, think about this. Something as ancient and fundamental as blue eyes, something that has been used to group people into different categories for generations, is actually younger than farming itself. It is younger than Stonehenge, younger even than the taming of wild horses. We view certain human traits as eternal and ancient, when in reality, they are, on an evolutionary scale, basically brand new. The human blueprint we take for granted as normal and permanent is actually still being written today. Let's step back and see the bigger picture. Take skin color, a trait that has driven so much of our history, built political systems, and fueled terrible atrocities and divided US into hierarchies for millennia is, at its core, a simple ultraviolet calibration tool. Think of it as a dial, a natural tuning mechanism, your body's inherited best guess of how much solar protection you need. based on the latitude your distant ancestors lived in, the diet they relied on, and the climate they had to survive under. Fair skin is not superior in any way. Near the equator, it is highly dangerous. Too much ultraviolet radiation, more DNA damage, higher cancer risks, more folate destruction. Light skin in Africa was a serious disadvantage. Darker skin is not some primitive or less evolved trait. It is the ancestral baseline, the original design, the default from which everything else is just a tweak. Honestly, having lighter skin is actually the newer adaptation, the variation. Dark skin is the default. And here is the ultimate cosmic irony. The exact same sun that forced some groups to pack on melanin to survive its harsh rays also pushed other groups to ditch it because they desperately needed more of its scarce energy. The sun did not pick sides. It had no favorites. It just beamed down indifferently, leaving evolution to sort out the rest. Think about it. We built generations of deep prejudice, cruel hierarchies, all over a vitamin D issue, a calcium absorption quirk, or a folate protection mechanism. Our species is actually still evolving, slowly, almost invisible to our short human lifetimes, but it is happening. The survival pressures that shaped skin shades are still lingering in the world, even if modern technology has dialed them down. We have vitamin D supplements now. We have sunscreen. We have fortified groceries and electric lights, cozy heated houses, and limitless food shipped from every single latitude on Earth. We have built a world that separates our skin biology from its historic purpose. Nature's grand algorithm is still running, but we have swapped the rules. What that means for our species over the next 100,000 years, nobody can say. Evolution doesn't send out weekly newsletters, but what we can say with absolute certainty is that every shade of human skin we see today comes from that same ancient family standing under that hot African sun, slowly migrating across an unpredictable world, carrying along with them a record written in their melanin of every single climate their descendants ever encountered. Each skin tone is an answer to a question asked by our star, and every single answer was spot on.